So I'd like to introduce Dr. Yue-Ting Siu. Ting is a teacher for the visually impaired and assistant professor in the program for visual impairments in the Department of Special Education at San Francisco State University. Her talk today is titled Haptic Applications to Education with Students for Visual Impairments. So can everyone please join me in welcoming Ting?
Thank you. Thank you, everybody. It's quite an honor to be here. I feel like there's a lot of intellectual capita in this room, so I'm very honored to be included in the group, I guess. Just in hearing the first session, it was very impressive to me, the interdisciplinary nature of the conversation. I feel like there's so many experts in this room from different areas, and it's quite incredible that we've come together in this space. So I think that's really cool, and I think that's kind of the platform I'm going to spring off of for this session. Okay, so how many of you guys know what the acronym T.V.I. stands for?
I do.
Woo! Okay, who said I do? Nick, what is a T.V.I. to you?
And besides the actual teacher of the visually impaired,
Yeah, what does that mean to you? What does a T.V.I. mean to you?
it means someone that's overworked.
Underpaid, yeah.
Underpaid. Oh no, I'm done.
Okay. So I don't want to over or under assume the expertise in this room or the knowledge of what a TVI is, but just so that we're coming from the same understanding of what exactly is a TVI, I wanted to just take a little step back and define what a TVI means to me and how I think of what a teacher of the visually impaired is. So first and foremost, as a TVI myself and in the training program at San Francisco State in mind melding future generations of TVIs, I really think of us as taking on a role in supporting families first and foremost, and also supporting school teams to really interpret what student needs are, needs in learning, understanding information, accessing curriculum, and how we translate those needs for both in the family context, but also the context of learning and development in school systems. Speaking of school systems, oftentimes the TVI ends up being a community advocate for both the student who's visually impaired and for their families and for their educational teams, because we have to advocate for what the student needs in order to have those equitable opportunities for achievement as their studied peers. So how does what's part of like the TVI being overworked, as Nick said, and that was just so perfect because, we really feel like we are often overworked because we have lots of responsibilities. First and foremost, I tend to go back to our responsibilities in providing instruction in the expanded core curriculum, with the understanding that first we have to assess what those needs are. So TVIs look at the expanded core curriculum, or the ECC, and these are 9 areas of learning and development that most oftentimes require direct instruction for students who are visually impaired. And these are areas that most sighted students don't need direct instruction on because they learn these things incidentally just by like visual observation. So examples include some of the 9 areas are: number 1, compensatory skills, so recognizing where those gaps in understanding concepts are when you don't have vision. One example I use a lot is the idea of like condensation and evaporation, where toddlers start getting exposure to this when they see like water boiling on the stove, or how steam happens, or big clouds in the sky. So as a TVI, to recognize that our students might not have had that experiential access, that they actually need more direct instruction to understand those concepts, that's part of compensatory skills. Number 2 in the ECC is O&M, orientation and mobility concepts. So this really directly relates to your guys' work in helping our students build those like spatial representations, the mental mapping, but what kind of prerequisite skills might students need in order to even build those mental maps? The third area of the ECC is social interactions. So recognizing that students need direct instruction to do those high fives or handshakes or nodding. body language and things like that. How can our students pick up on those visual social cues in a non-visual way? Number 4 is just independent living skills, getting our students ready for independent living, recreation and leisure, making sure our students can access those same opportunities to rec and leisure. This really facilitates our students' inclusion in the community, the greater community, the mainstream community. Number 6 is career education, so ensuring that our students have the adequate skills to carry out employment tasks to achieve to the same extent as sighted employees can. Number 7, huge, is use of assistive or access technology. And this isn't just using the VI specific tools, but how do our students also need to access the mainstream technology? Our sighted students can see people keyboarding and see people clicking on things. Our students need that direct instruction to understand spatially how information is laid out in that digital environment, okay? Number 8 is sensory efficiency skills. And this also, I think, has great relevance to your work because it's how do we help our students develop the use of their senses for that multimodal accessibility, or do they really need single modal accessibility for certain tasks, okay? And how do we differentiate that for different students? I think somebody earlier mentioned something about working from a person's strengths, like let's identify the strength of access, like what's the strongest sensory access point for a person. Part of this is helping our students recognize which sense is most efficient for them to use to access information across different tasks. And the last area of the ECC, the Expanded Core Curriculum, is developing self-determination skills. And I think this comes naturally when you develop skills in all the other areas. When a student feels able to access information, be independent in their access, have timely access, then they really feel like they are an agent in their own lives and being able to dictate their learning and work practices. So, a lot of this aligns with the T.V.I. taking on the role of an accessibility facilitator. When I walk into a school or various classrooms, whether it's a classroom for students with moderate to severe disabilities, mild to moderate disabilities, or a mainstream general ed class where the students just got visual impairments and they're otherwise in a classroom with sighted kids, how do we ensure our students, our VI students, can access any level of the curriculum and academics that their sighted peers are getting, regardless of their school placement? That's really the role of the T.V.I., is to define where those breakdowns are in accessibility and figure out, okay, how are we going to make this happen? So I feel safe saying this, that I think TVIs are like the MacGyvers of teachers. I said this with a group of undergrads last week and they didn't know what MacGyver was. Thanks guys for knowing who MacGyver is in this room. And I think the last, and sort of this emerging role that I feel TVIs can take on now, is being a translator. So, not just translating between the student needs and the families and school teams, but now with the infusion of technology in our classrooms, the implementation of more digital learning systems, online learning systems and assessment, we're uniquely positioned to translate student needs and classroom needs to the technologists, to the scientists who are designing and doing the research and development in these tools that can potentially be critical access points for our students. So, speaking of access points, what are some other considerations in supporting students with visual impairments? Number 1, as a TVI, we start with identifying what are the functional implications of a visual impairment for the student. So there's a saying that's overused, but it's so true, where if you have met one student with one type of visual impairment, you've met exactly one student with that type of visual impairment. So the functional implications of everybody's visual impairment is going to be very unique to that one person. You're never going to have two people with the same diagnosis with the same exact functional implications. So this is a really fun part of teasing out, what does this person's functional implication of their visual impairment, what is that? What does that mean for this student? In order to tease that out, TVIs carry out learning media assessments, or LMAs. And this helps us define what those students' needs are for learning media. So, from the designer point of view, it's how do we need to design the learning materials to ensure that our students can access the information and access those materials in the most efficient way possible for that student. This is where I see a lot of opportunities in UDL, the Universal Design for Learning, the improvement in mainstream accessibility. So we're no longer just differentiating for this single VI student in a room, but when you can design well, that student is basically, they could take advantage of whatever features are needed to pull down information in a way that's going to be efficient for their mode of sensory access. Okay. So the other part of the learning media assessment, though, is first identifying how those instructional media need to be represented for students. But the other side of that is, what are those sensory skills in the students that we need to fine-tune to make sure they can access the media in all these different formats? So, for example, if you're talking about multimodal access, does the student need to have more refined tactile skills? Do they need to have some better, mental mapping or spatial representation to even access media in these multimodal ways? Can the student multitask visual with auditory access, or do they really need to go to one mode for different tasks? Okay. And figuring this out is not an easy process. The first part is this assessment piece, but the second part is designing an intervention program based on the assessment data. This is why I was particularly interested in Gordon's talk, where he looked at the tactile acuity differences, and my immediate question was, okay, well, what's next? You have this assessment data, what's next? How do you build an intervention plan for that? How do we make sure our students have the skills to access the content that's going to be represented in this other way? As a TVI, we always work from the core curricula. That's sort of the where we shoot for. That's where we set the bar. So the core curricula standards state what all students in the school are expected to achieve to. And for our students, we have to then translate those core content for, okay, how do we now represent this in an equitable way? But it might need some alternate representation for our VI students. But when we alter how the content is represented, are we still conveying the same concepts, okay, in that non-visual manner? So this gets interesting because as TVIs, we are usually told, you are not content teachers. You have to just, translate this in a different representation for the students. But we're not English teachers, we're not the math teachers, we're not the science teachers, we're not the content teachers. We're the accessibility facilitators. However, in order to really translate the core curricula in such a way that it's represented to convey the same concepts, I feel like you really do need to have some content knowledge, I'm not a math expert, but if I need to figure out how to make this lesson about, differential equations, that's a math thing, right? If I need to figure out how to make differential equations accessible to a student, I need to make sure I'm representing this in a way where in this non-visual format, they're still getting those concepts in that same way, okay? So I would actually have to learn enough about differential equations to represent that alternatively. And I think that's the challenging piece in this part of multimodal representations, is making sure we don't lose things in translation, okay? So moving on to considerations for technology integration as part of this translating information from one format to another, we ultimately have to start with the student. Everything always has to go back to the student and really identifying that student's needs, leveraging what those students' sensory learning channels are, and then designing a program from there. And I know probably from the technologist's point of view, that's impossible because you want to grab onto this technology and design from there and then find a suitable fit for that. But for really good adoption, for that user adoption, as teachers, we always start from the student first, and then we kind of shop around for what technologies are going to fit. all the while respecting the individual differences between students, with the different visual impairments and the functional implications of their visual impairment. So when we think about, as teachers, when we think about how do we choose technology, how do we integrate a new technology or a new mode of access for our students, one thing that we need to remember is the context. So what is the context for this tool adoption? I listed on the slide infrastructure and efficiency. So the first point, infrastructure, what I mean by infrastructure is what kind of a classroom is a student learning in? How busy is it? Is there Wi-Fi? Is there room on a student's desk to have an extra device? What are the students already using, and can it be enhanced in a certain way? Our poor kids, even the sighted students, they have these like rolly backpacks now because they can't even carry their backpacks on their shoulders. Then you've got the poor low vision or blind kid who needs extra tech. And with mainstream technology being more accessible, it's gotten a lot better. But inevitably, our students have to carry around multiple devices and tools. So what is the infrastructure to support like a holistic toolkit for accessing their work? Along with that, building that toolkit is figuring out what's the most efficient mode of access. So 3D printing is like this hot thing for how we can like represent different things. But is 3D printing the most efficient way to make Braille for a student? No. I mean, it works, but it's not the most efficient because the student's gonna have to wait like 8 hours for a thing of 3D printed Braille, right? That's not the most efficient way. So part of that is figuring out, okay, let's really take a step back and consider what really is gonna help increase the student's efficiency of accessing information. And that always is a critical point for both students and teachers, because again, as Nick said, we're overloaded. So we need things that are also going to work into our own workflow and into what we're already teaching our students. My last point on this slide is collaboration is epic, exclamation point. And I think this is a huge opportunity for collaboration where teachers can really benefit from collaborating with the people who are designing for their students' use, And I really hate to say it, but T.V.Is end up being the gatekeeper for technology adoption in VI students because we're the ones who have to translate what the student needs and translate what technology is going to work for the student and how to teach that. And that's also a big challenge is how do we get these teachers aware and savvy about what the options are and how to make good decisions about which technology to choose. So kind of to wrap us up, I coordinate the T.V.I. program at San Francisco State. It's kind of funny to be here because Amanda Lueck, I kind of inherited the program from her, so my predecessor is here too. But I wanted to present just my personal philosophy of teacher preparation. So this is really just like, Ting Siu's kind of thinking. But in my program, I really hope to inspire a framework for thinking in my teachers. Yes, they need to know what the assessment tools are. Yes, they need to know the curricula. Yes, they need to know, how to write a lesson plan. But ultimately, they need to know how to think. And, I see all the stuff happening in technology and all of the new affordances of digital media and multimodal access. And we need to nurture design thinking in our teachers just as well, because ultimately they need to think as designers and think about what the user experiences are like for the students in the classroom. So I hope to do that for my teachers because I think it gives them a more global view of how to consider tools and supports for their students in the classroom. And it can help advise on how to construct more accessible learning environments for students as well. When I think about what our instruction breaks down to, I kind of see it breaking down into two camps of, teaching our students how to use the tools, teaching our teachers how to use the tools, but then also making sure that their environment, the learning environment itself is also accessible. So that's part of that, being a good community advocate and being able to translate needs between fields is as much as the learning environment can be just accessible out of the box, I can really focus on just getting the students and teachers knowledgeable about the tools to access those environments, okay? That's going to take out a lot of our load if, the environment's just good to go right there, okay? Because, our wheelhouse is really that pedagogical part of how do we use the tools and what tools are good. I also really want to encourage my teachers to decipher those user experiences for equity. So how do we make equitable user experiences for both teachers, but also for students? So, if we're going to throw new tech, let's make sure that our T.V.Is aren't having to go an extra mile to figure out this technology beyond what the gen ed teachers already have to do. Same thing with students, that they're not going to be an added burden, but actually it's going to be an equitable experience in general in using technology. Deciphering user experiences for empowerment. So when we have equitable experiences, then we are empowered to say, hey, we're in the same space here. We've got the same advantages or disadvantages as anybody else. And that's, I think, how we can get teachers to achieve to the highest standard of teaching and also students to achieve to the highest standards of learning. And again, collaboration is epic, exclamation point. Where, in the teacher prep program, we have to start building these habits of collaboration across disciplines. So with scientists, the instructional designers, the technologists, we have to build a language for collaboration. So, and I think that's a good segue to our panel where we'll have a couple different perspectives from the educational field.
Thanks so much, Ting. Okay, so now we'll have a panel discussion about Ting's presentation. And the panelists include Dr. Amanda Lueck, Lucia Hasty, and Dr. Paul Bulakowski.
I'm Amanda Lueck. I'm a professor emerita from San Francisco State University.
And I'm Lucia Hasty, and like Ting, I spent most of my career as a T.V.I, and now my focus is on tactile graphics.
Hi, I'm Paul Bulakowski. I have training in perception and action, and I am a co-facilitator of a low vision group over on Berkeley campus and an educational entrepreneur.
Okay, so I heard some grumblings up here, like, I thought we were talking about haptics. Where's the haptics conversation? Okay, here we go. So, I wanted to give you the context and the background information so that we have this, again, shared common language when we really do address haptics in education. So for the panelists, I was wondering, given the learning media considerations for our students, how can the learning media assessment and learning media process be tailored to support or train up a student's skills to be able to handle haptics applications?
I'll give a stab, and I just want to say that I'm coming from a very similar angle as Ting, is that I'm seeing learning, whether or not it be through your sense of touch, your sense of vision, or all your senses, as kind of having a common denominator. And the learning science research suggests that self-assessment is an incredible way to get feedback on haptics devices or training, and it's something that empowers the student to have a voice in their progress.
For centuries, I guess this is on, we've basically run the field of teaching blind and students with low vision on folklore. We have not had the kind of knowledge that is now being so much more studied and published and more available to us. I'm very, very excited to be part of this because it will allow us to know how students learn. We keep teaching them to do things, keep going over and over and over, and they may or may not get it because we've not known exactly how students who are primarily haptic learners learn. And it's not the same as sighted kids. We do know that part. So it's exciting to look at all of the information that's happening. I just encourage all of the researchers to keep going and keep publishing.
Well, I'm in a little bit different position than other people on this panel. And Ting asked me if I was a glutton for punishment, and I am, so I'm going to present some different viewpoints. But I thought about it, and I thought if I talked to Val about this, she would be really open, and she would be thinking about the research aspects of it and how to deal with it. So I'm just going to do it. One of the things I want to talk about in terms of a learning media assessment is the use of Braille. And something came across my desk a few days ago. It was a system, an alternative system for Braille, and it was called the ILIA. And apparently it raised a lot of hackles with people because, you know, Braille is sacred. And when I saw it, I jumped for joy because you could type some print in and it would translate it right into the ILIA system, which is a much simple system based on some symbols. Those of you who know the history of Braille know that in the 30s, there was a meeting called the War of the, and a book about the meeting called the War of the Dots. And there were different systems for reading at the War of the Dots presented. And one was Moon Type, one was New York something or other, and then there was American Braille. And the reason that they chose the Braille system that we're using now, although that's just been shifted a little bit, is because of the existence of the Braille writer. It was because of the technology, because they could produce the Braille. It wasn't that the Braille was the best reading system, it was because they had a Braille writer. About, was it 25 years ago, the visionary Jim Bliss developed the Opticon, where he translated print right into optical characters. And at the time, myself included, people thought that this was a transition to auditory reading for the blind. It was a way of, you know, just a transitional device. But I guess he knew that 25 years later, we would have the technology to translate print directly into optical characters. There also was Moon Type. Moon Type is a system of raised symbols, and it never made it. But in England, it's used by elderly for reading print, and it's also used by children who are multiply impaired. Now, when I came into the field, and I won't tell you how many years ago because it's embarrassing, I became most interested in working with young children and children who had multiple impairments. Those children are at an incredible disadvantage for literacy and reading because the Braille code is so complicated. And so where a child with the same cognitive capabilities would be able to read print if they were sighted, typically sighted, they would not be able to read if they had reduced vision. So I think we're at a crossroads again for thinking about what to do in terms of reading for children who are visually impaired. And that's not to say, I love Braille. Braille is incredible. It gives people access. The ways that Braille is accessible now, they're incredible. But we also have to think about the use of technology to promote reading and literacy, especially for seniors, and most of the people who are visually impaired in the country are seniors. And you saw from Gordon's discussion that if you're not a Braille reader from a relatively young age, your ability to tactily distinguish the Braille dots goes down. If I know Braille, but I know it visually, If I had to learn Braille now, I would have a very hard time. I would do it, but I would have a very hard time. There have to be some ways of doing this and bringing the consumers, the blindness community along so that they have access to literacy, not just auditory literacy, but tactile literacy in a way that's not so straining. So I'm a glutton for punishment. I brought that up. The other thing that I want to say is think of, I'm going to say the words, Sesame Street. Sesame Street was a game changer. I had a friend who was a producer at PBS, and she said it changed the whole way everybody thinks. If you think about the world before Sesame Street, if you think about movies, if you think about TV, remember there were long takes and you could actually look at people's faces and see all the details on their faces. Now, if you think about the movies, the TV shows that you see, they're presented in a totally different way. Very short takes. You have to think about what that does to the mind, to the way that we see the universe. It's totally changed the way we take in information. I'm working on a book now, and I'm changing the whole way I'm going to be doing the book because people don't read. They don't. Now, when you think about developing technological solutions for people with visual impairments, you have to think about what the implications are on cognition and the way the mind works for the way the haptics are presented. And is this going to be advantageous? Or is it going to cause some problems? Or are we going to be able to use what you guys are doing with the haptics to really promote improved cognition and the correlation between perception and cognition for people who are visually impaired? And I better stop now.
Oh, puppy. I just want to build off of that point. As a collaborator with Dr. Val Morash, I think something that, and as someone who's made the jump over into sort of applied technologies, I think Val really nailed it in terms of her objectivity, and that was mentioned before, but then also in terms of her precision. It's not the right time to just try to get that headline to look just right. It's time to get the really deep science right. And that's where Val excelled. And it was also, that was a point of a great challenge in collaborating with Val, is it was never good enough. And it was to the limits of physics. And I think that the basic researchers who are continuing basic research really need to stay humble to the data. And that's a good first start to get it to be more useful. And then
I agree with him. But yeah, I just wanted to agree about the usefulness of the data. I think we finally are into an era in which that data is really connected to what happens every day out there with blind kids in schools, and continuing to be vigilant with the data, sharing the data, and then look at that data being able to be applied. There are lots of wonderful pieces of technology out there now. There are more being developed. We just need to keep working on seeing whether or not that technology is useful to kids. We can give kids tons and tons of tools, but if they're not trained to use them, or if there's not any immediate need for that use, they're not going to use them. So I think just continuing to do that collaboration between developers and researchers and the actual field of working with both kids and adults is really important.
And this is not a problem only in blind and visually impaired, education for the blind and visually impaired. This is a problem, I think, across education for all, and I think that broadening, again, going back to Ting, one of Ting's main themes of broadening out learning science and what we ought to be paying attention to if we're looking for haptics learning, we ought to be looking at the more general education field and what's known there about how people learn.
Yeah, and I think it's important that as really robust, rigorous studies are carried out and we're collecting all this data, that the data can also be translated into the different applications across fields. So, there's really rich, cognitive data, and then learning sciences data, human-computer interaction things, user experiences. How do we translate really good data, but to bridge applications and put everything together so that, we can figure out how to move our field from best practices to really evidence-based practices. And I think we need good translators in each field that can then work together and create a conversation that can be understood by people in all the different fields too. So let's see, how much time do we have?
We haven't pulled out, our lunch starts at like 11:20 or 12:20.
Oh, okay. Great.
Can I ask a question to that point? Is that okay?
Yeah, perfect.
My name is Abby Stengel. I'm from the Atlas Institute at CU Boulder. I'm curious, because you guys are thought leaders in this field and we have a room full of experts. What are the most confusing concepts from cognitive science and perception in your own ability to be translating that? Because I think drawing on your experiences will allow us to start to abstract those into more pedagogical moves for T.V.Is, for example, and instructional designers.
I'll start broad. I think we need to start unbiasing ourselves. There's a lot of cognitive biases. We had a conversation over here about visual illusions. There are haptics illusions as well. There are cognitive illusions. I think we're deluding ourselves if we don't first address these cognitive biases and how they get in the way of what we think is good education. And I think that really, for a room of scientists, this isn't hard. You just go and read and do science, and that should get you out of a bias. So again, just going back to writing unbiased and doing unbiased as possible research that's localizable, flexible, generalizable, goes across the senses. Because really, you use whatever senses you have, and we can argue about how many senses you have.
I'll piggyback on that. I think that we have to stop thinking about people who have disabilities as needing fixes. They don't. They're fine. And we have to start looking at how they learn and what is best about how they learn and build upon those things. Some of you are already doing it, but thinking that everything that has to be made the same and normalized, well, what's normal anymore? I don't know. As Ting so rightly mentioned, one person with a visual impairment is one person with a visual impairment. And how they learn, they're a complete being. They have a whole system. They come with a whole set of experiences. They have all their neuroses and all their conditioning. And to assume that they have to be made the same as everybody else is just not the way to go. And I like it that Paul says that, you just have to think about this across the board.
And also I think specifically about translating the information across fields. I mean, in my teacher prep program, I give them direct instruction on, hey, what is the vocabulary you have to use when you talk to an IT guy? Or what is the vocabulary you have to use with a software developer when something is broken and you need them to fix the accessibility of an app, let's say. But it's helping my teachers have the right vocabulary to use to communicate with the different people they need to advocate with. But on the flip side, I think as the data starts building and building from all the different fields, teachers also need to have, it's got to be like that two-way street of everybody developing that shared vocabulary to communicate the data to teachers. And that's why I spent so much time talking about the ECC, the Expanded Core Curriculum, and Learning Media Assessment, because that's really what the teacher's wheelhouse is. That's our pedagogical knowledge. So if the data from these cognitive science, learning sciences, HCI fields could be translated in terms of how does that fit into instructing the ECC? How does that fit in terms of defining learning media for our students? How does that fit in terms of helping our students leverage their sensory learning channels? That can help teachers really translate that into instruction and practice, I think. Yeah, Nick?
Quick question, Ting, or for any T.V.Is. So you mentioned that a big, I could, and I guess I will. You mentioned that a big role, or one of the roles of T.V.I. is to learn the technology and to be able to, be able to help train the students. But I'm wondering, from the standpoint, how do we better, besides what we're doing here, how do TVIs, which are kind of boots on the ground, help scientists and engineers? You know, we can go down the parametric wormhole of manipulating this variable or that. But sometimes at the end of the day, I'll talk to someone that's saying, well, actually, really, what we need to figure out X. And I've been studying Y and Z because I thought that made sense scientifically. And so I think there needs to be this, we're all talking about crosstalk, but there needs to be some mechanism to try to facilitate that. And I think that's what we're doing now. But I think it's also, it's hard because everyone's busy and people, run in different groups or circles or back to my silos. But do you have any ideas on how to better facilitate this communication so we are kind of working synergistically instead of independently?
Do this again and again and again and again and again and again. Just keep on doing it. I heard, and I know that educators and educational institutions need silos because we do need to make distinctions. It's a key feature of critical thinking and being able to label something exactly. But we need to also be able to understand the vocab of other people's silos. And just keep on communicating.
I think it's really easy to preach to the choir. So, for us, it's, TVI is going to our own VI and educator conferences, HCI people going to their HCI conferences. But I think there's a lot of value for, our TVIs to go to a learning sciences conference, or vice versa for a technologist or an HCI person to go to an educator conference. And I think that's the best way to learn about the cross vocabulary, is to really just commune with the people that you want to communicate with. And I think that is a challenge because we're all busy. So, it might just even be like lurking on various Facebook pages, and kind of lurking in that way. I try to challenge myself to go to a non-VI conference, once a year if I can make that happen. And I think that's where the greatest impact is in being able to translate ideas across fields.
Sheila from the University of Michigan. It strikes me that in thinking about making educational material accessible, we often think about one solution for a given problem. But if I'm thinking about how my sighted students learn about, for instance, the fundamentals of acoustics, I often try and present the same material in multiple ways. And I think, we just have to be careful not to come up with the correct solution, and to realize that we need to offer visually impaired students multiple paths of access into concepts as well.
I think we all agree.
This is Gordon Legg. Oh, am I on? Is it green? Oh, okay. I want to get back to a point that Ting raised about multimodal versus primary modality. I'm just wondering if you have a kid with low vision, how do you decide Braille, audio, magnifier, or all of the above, or do you make a selection on a primary modality? I'd just be interested in your comments on that challenge.
I feel like we're all smiling at each other up here because we're like, oh God, that's like hours and hours of assessment, basically. So, there's formal and informal assessment measure or tools that we use, lots and lots and lots of observational data that we look at. Of course, check-ins with the student who's like the end user. But this is part of that, the whole functional vision assessment and learning media assessment. And I think the important thing is that it's a process. And, you know, you kind of take your initial evaluation, you make some recommendations, and you're always constantly assessing as part of diagnostic teaching.
And I think the other piece of that is, what does that student in that learning environment need in order to access the learning environment? And that sort of becomes the crux of the question that you ask over and over again. It's not a static decision at all. It changes as the tasks for the students that change. One of the things I wanted to add, do you want to go with that? Okay. One of the things I wanted to add is that the developers have worked really hard at creating things for students to be able to read. We think of literacy as reading and writing in a particular language, be able to read. And so we have all kinds of Braille things, and we have all kinds of audio things. We are not focusing on the communication from the other direction, on writing, on communicating in a concrete kind of a form. And that's a huge, somebody looking for a new research project, there you go. That's a huge area that we really need to focus on. How is it that we can have students who are visually impaired communicate back, as opposed to just being takers? How can we have them being givers back without writing it on the Braille writer or writing it in some Braille form? What if you need to communicate in another way? And thank goodness we've got people working on graphics displays and that kind of stuff, which is great, but I think more emphasis needs to go on that.
And the only other thing I wanted to add is, when you do a learning media assessment, you may not use the same medium for different subjects. You might use something for math and something for reading, and something different for something that's going to be very, very taxing, and use auditory for a college textbook. So a learning media assessment will differentiate the instruction based upon the kind of material that you're using.
Ken?
From a developer point of view, I'd like to ask if there's any feedback loop from you guys to things like the BANA committee and stuff, because one of the things we ran into with what we're developing is there are no standards for refreshable tactile graphics at all. There's nothing, I mean, there's tactile graphics, you know, we're talking paper and 3D and stuff. There's certain people working on it, but there's nothing, no guidelines on distances. And this I'll probably say this later, but this is something Val was going to work on for us. But do you guys have any feedback into that loop, or anything you know about, or?
Well, I would just say that everyone here who works in this community, if you're working for an institution and maybe you're advocating for a particular student with a particular need in a particular context for a particular goal, to go really press like the Center for the Students with Disabilities or whatever center at your local institution, because likely the solution is going to be local. And so if we can produce a number of local solutions that are driven by the person who has that need, and just advocate within your own institution, and I think that will excite the non-visually impaired students and the people who have had no contact with this. This is the younger generation of researchers that we so sorely need. They need to be seeing people with the disabilities excelling in their coursework and really wanting, as it often is the case, if we develop a solution that's great for the visually impaired, it usually helps out the sighted. So I would just advocate for being a local advocate for your local problems. And if there is an issue with a device or a technology, don't be ashamed to write the technology company and the person who's having the issue with it, because they might have problems making that communication. So be an advocate for them. But that's only my point of view.
Josh?
I just want to, it's Josh. I just want to address, Ken's point is actually a great one. And the idea is that we're so accustomed to using, finding the materials that meet our needs. So we use collage, we use tactile graphics, we use all sorts of things. We're at a new stage now where we have a new set of technologies that are able to create these refreshable arrays of, either tactile dots or other types of tactile representations. They're not ideal. They're not high resolution. They're not exactly what we would want, but they are what we have. And I think what Ken is asking is, where's the research that's going to guide us in using these imperfect low resolution displays to their best effect. And I'll just say, Ken, that Smith-Kettlewell, although Val is not going to be doing that research, Sheila and I are still committed to that research, and a number of us here are. And I think that there are a number of other people across the country and the world who are realizing that with the proliferation of these new technologies, we need to start thinking very carefully and clearly about how we can use those displays to best effect. I don't think Bana is your answer.
I mean, I also wonder, talking about like equitable translations, across modalities, I'm totally with Sheila's point in, hey, our students need options and they need to have the freedom to choose how they want to access information. So similar to how sighted people can adjust font size and click things to make fonts larger and smaller, can't you just make your refreshable displays, adjustable to adjust the pins, closer or further, sort of the tactile equivalent of font size changing?
So give us some years, but what I'm going to show today, you can already adjust fonts, and I already know why people hate Sanskrit. What is it called? Sans serif. There you go. So, but I'm going to show you some of that later.
Okay, I think that's about time. Let's thank our panelists for a wonderful discussion.